The skill of balancing equations is a very, very important concept in chemistry and is driven by something called the law of conservation of mass. The law of conservation of mass basically states that matter which we know comes from atoms, cannot be created or destroyed in a chemical reaction. So to illustrate what I mean by that, let's take a look at a pretty simple basic equation. Alright, this is the reaction between hydrogen gas and oxygen gas to form water. When you combine pure hydrogen and oxygen together and you give it a little spark, the bonds between the hydrogen and the oxygen atoms in the diatomic molecules are broken and they rearrange to form water molecules. Remember, we say that's what happens in a chemical reaction. Now I'm going to do this a little visually here. I'll draw a little picture of a hydrogen molecule here. Okay, the blue balls here will represent the hydrogen atoms, and they're bonded together because hydrogen's diatomic. And then I use a red here to represent oxygen. Now on the right hand side, this is water. This is H2O. That means there'll be one oxygen atom bonded to two hydrogen atoms. Now the first thing you should notice is that it appears that during this reaction one of the oxygen atoms just vanished. Now we know that that can't happen. So the question is, where did the other oxygen atom go? Well, it can't just disappear or vanish. And it's not just going to turn into O floating around over here. It's going to be part of a second water molecule. Okay, so the two O's, when they break apart, each one of them goes into a water molecule. So to show that, I'm going to put the number 2 into the equation in front of the formula for water. Well, now the problem is now I have 1, 2, 3, 4 hydrogen atoms, but on the left side of the arrow I'm only beginning with 2 hydrogen atoms. Well, the law of conservation of mass says whatever I start with, I have to end with. So let's show that. With 2 hydrogen molecules on the left side. Let's put a number in the equation to show that I have 2 hydrogens and 1 oxygen. And when those bonds break apart, they're going to make a total of 2 water molecules. Now these numbers that I just drew in here and added to our chemical equation are called coefficients. And when you balance an equation, that's what you do, is you go through and you add coefficients so that you have the same number of atoms of every element on the left side of the arrow and on the right side of the arrow. That's called balancing the equation. So let's look at some nice examples here. Alright, let's look at some examples of balancing equations. So right here. Okay, there are some general rules for the order in which to balance elements in any chemical equation, just to make your life a little easier. So first of all, you should always do metals first. Okay, then you should do polyatomic ions if they don't appear to be broken apart as part of the chemical reaction. Okay, and then you can do all the other elements. You do oxygen last. The reason that we do oxygen last is because oxygen tends to appear all over the place in a lot of chemical equations, and it just seems that if you balance everything else and then you wait to the very end, oxygen tends to get itself balanced while you're working on everything else. Alright, so let's take a look at some nice examples that we have here. So first of all, we have this reaction here with Fe and water making an iron oxide and hydrogen gas, where elements are Fe, H, and O. You notice they appear on both sides of the equation. Now, we're going to put a number in front of them if we need more. Okay? If we just need one, we're just going to leave it blank. We don't write ones in chemical equations. Simply writing down, right now we're starting with one of everything. So unbalanced, or sometimes called skeleton equations, you start with one of everything. So the number one rule is to start with the metals first. So that would be iron, Fe. On the left side of the arrow, there's just one Fe. On the right side of the arrow, there appear to be 3 Fe's. The subscript says 3, so I'm going to make that the same on the left by putting a 3 here. So now I have 3 Fe's and 3 Fe's. Okay, I have O, but I'm going to wait to the end. So I have 2 H's and 2 H's. Okay, so now it's time to balance the O. On the left side, there's no number here, so there's 1 O. On the right side, there's a 4. So now I need to make this 4 by putting a 4 here. So now it's 4 times 1. Now look what happened. This happens very frequently when you're balancing. The H's were balanced, and now I just ended up unbalancing them. Now I have 4 times 2, or 8 H's. All I have to do is go back to the other side and rebalance. So I need to have 8 H's, so I'm going to put a 4 here. Now I have 8 hydrogen atoms total. Okay, next example. I have nickel and iodine to make nickel 2 iodide. So metals first, 1 Ni, 1 Ni, 2 I's, 2 I's. Okay. If you run across an equation, sometimes the initial equations, when you simply write out the reactants and the products, end up what we call already balanced. If you run across an equation that doesn't need any balancing, don't just skip it or ignore it. Just put already balanced next to the equation and you're done. Okay, next example. We have aluminum bromide and chlorine making aluminum chloride and bromine. Metals first, Al1, Al1. Br3, Br2. Okay, the rule is that coefficients have to be whole numbers. So what could I multiply 2 by to make it 3? Well, 1.5, but that doesn't really work. So the rule is if you have like 3's and 2's, make them the least common multiple. In this case, this is 6. So I'm going to make this one. Sorry about that. In order to make this bromine 6, I'm going to put a 3. In order to make this bromine 6, it's already 3, I'm going to put a 2. Now, you'll notice what happened. Now I have 2 aluminums. So I need to go to the right side and also have 2 aluminums. I'm going to put 2 here. Now the aluminum's balance and the bromines balance. Okay, let's take a look at the chlorines. On this side I have 2. Because I put a 2 here, I now have 6 chlorines. So I need to have 6 on this side. 2 times 3 will make 6. Okay, next example. This is aluminum and lead-2 nitrate, making aluminum nitrate and lead. Okay, I have 2 metals. It shouldn't really balance. Let's check to see, matter which order I do them in. I have 1 aluminum, 1 aluminum, 1 lead, 1 lead. Okay, so what do I have left to balance? Well, I have NO3. Now it's in parentheses. That means that this is a polyatomic ion. And the 2 outside means I have 2 of everything inside, so I have 2 nitrates. On this side there's a 3, meaning I have 3 nitrates on this side. So in order to have the same number of nitrates on both sides, you treat the nitrates as though they were a special element. So I'm going to make them both 6. Again, So I'm going to make this one 3. That's 3 times 2 is 6. On this side, 2 times 3 makes 6. Well, by balancing the nitrates, I changed the metals. So now I have 2 aluminums on the right, so I need to make 2 aluminums on the left. I have 3 leads on the left, I need to have 3 leads on the right. Okay, only a couple more. This is what I call a CHO problem, where you have carbon, hydrogen, and oxygen, CHO. Balance them in that order. Carbon, then hydrogen, then oxygen. Okay, 3 carbons on the left, 1 carbon on the right. So I'll put a 3 here to make it 3 carbons on the right. 8 hydrogens on the left, 2 hydrogens on the right. I'll put a 4 in front of that. That makes 8 hydrogens. Now, with CHO problems, your oxygens are in 2 different things. You have to count the total on the right. So I have 3 times 2, so that's 6 O's are in here. 4 times 1, 4 O's here. Total of 10 oxygens on the right. I need 10 on the left, so I need to multiply 2 times 5 to make 10. Okay, next example. This is sodium carbonate and hydrochloric acid that makes sodium chloride, salt, water, and carbon dioxide. Okay, remember I said start with the metals first. So I have 2 NAs, 1 Na, so I'm going to make that a 2. So now I have 2 NAs on both sides. Okay, now I can balance these in any order except oxygens go at the end. Okay, so I have 3 O's on the left. Let's do carbons first. I got 1 carbon on the left, and this is actually on the right. Sorry, this kind of worked out. It didn't come out very well. This CO2 is actually over here. So 1 on the left, 1 on the right. Okay, let's go oxygen at the end. 1 H, 2 H's. Okay, let's make this 2. Now the H's are balanced. Now I have 2 chlorines and 2 chlorines. Okay, so far so good. Now let's count the O's. There's 3 O's on the left and 1, 2, 3 O's on the right. And I'm done. Okay, the last example I want to show you is some of the CHO problems tend to come out a little oddly. Let's look at this particular example of a CHO problem. CHO problems are really what we call combustion equations. We'll come back to that a little later in the unit. Okay, let's see what happens when we balance this one. Okay, on the left side, remember we do carbons first. 8 carbons, so I need 8 carbons. 18 hydrogens, I've got 2, so I need to multiply that by 9. Okay, now let's look at the oxygens. I've got 8 times 2, there's 16 over here, and 9 times 1, there's 9 over here. 16 and 9 is 25. Well, what can you multiply 2 by to get 25? Well, you have to multiply by 12.5. Now we said that coefficients have to be whole numbers. So if you ever balance and you end up with something like something and a half, all you do is you're going to multiply every coefficient that you've already written by 2. So this was a 1, so now it becomes a 2. The 12.5 becomes 25. The 8 becomes 16. And the 9 becomes 18. So what you've done here is you're keeping the appropriate ratio. They're still balanced, but by doubling everything, now you have whole number coefficients. So the tricks to balancing equation are count carefully while you're balancing. Okay, if you change a compound, double check to make sure. You're going to have to go back probably and balance something else on the left or the right side. And when you get to the end, double count everything before you say you're done. So I always suggest that you balance your chemical equations in pencil until you get much better at them.